So question 14, express root 3 sine x minus cos x in the form of k sine x minus a, where k is greater than 0 and a lies between 0 and 360. This is a wave function question. So what we're going to need to do is we are going to need to expand this expression in with the correct terms, and then we're going to need to find the coefficients. First of all, we'll expand this expression. So k sine x minus a. So this then becomes k sine x cos a minus k cos x, sorry, a bit neater, cos x sine a. Alright, and if we write our expression that we've given underneath it, I'm going to look for the coefficients. So we've got root 3 sine x minus cos x. Okay, so what are our coefficients? Well, we want to find what the k cos a, and we want to find the k sine a. So the coefficients are, well, they're going to be root 3, the sine x root 3, and we're going to see cos x is going to be this kind of invisible negative one we can't see. Okay, but there's a trick here, so you're going to have to watch out for what happens. So then if we're said, for the first one, we say k cos a equals root 3, that's fine. What about this next one? Well, here we don't necessarily have k, we've got minus k, so we have minus k sine a equals minus 1. Well, actually these minuses are just going to cancel, so you're left with k sine a equal to 1. Right, so there are your two coefficients here, there, and there. Okay, so the next thing we need to figure out is we need to figure out the value of k. So how do we do that? Well, we know that k squared is equal to root 3 squared plus 1 squared, which equals square of root 3 is just 3, square of 1 is just 1, so equals 4, and k will equal the square root of 4, so k equals 2. These are all k squareds, by the way. Okay, so k equals 2. Good. Right, so that's the next bit dealt with. Okay, so what do we think about next? Well, we think about the angle of A. So how are we going to figure that out? Well, we know that tan A is equal to 1 over root 3. This is just because of the sine A over cos A, just so you know. Okay, and then, okay, so how are we going to work this out? Well, this looks a bit nasty. Well, you might actually recognize some of these angles from our triangles, so let's have a look. So what ones do we have of root 3? So we've got 2, root 3, 1, and we'll have, this is our 60, 30, 90 triangle. Okay, so what is the tan of what tan of what value gives you 1 over root 3? Well, it's adjacent over opposite, so 1 over 60, so 1 over root 3, so that's going to be 60 degrees. So not 60 degrees even, my apologies. That would give you root 3 over 1. So what actually we're looking for is this angle, so adjacent, opposite over adjacent. So that's going to give you 30 degrees, because that equals so A is going to equal 30 degrees. Right, good. Okay, so now we need to think about the quadrant. Okay, right, so we have C, A, S, t. So think back to our two coefficients here. Right, well, they're going to be positive. This one's going to be positive in the first and fourth quadrants, and this one's going to be positive in the second and first quadrants. So that we're going to be looking at the angle in the first quadrant. Okay, so now we want to write out our final expression, which is going to look like this. K sine x minus a was equal to, well, we figured out k was equal to 2, and we know that sine, and then we worked out our a to be 30, so x minus 30, and that's our final answer there. Okay, so the marks in this question, you get 1 mark for using the compound angle formula here, and then you get another mark for comparing the coefficients, and you need to state them explicitly. You get another mark for finding k, and you get your last mark for writing this in the correct form. So that's 4 out of 4. Okay, great.